So looking at the PIQ environment, these 2 bytes here represent the space that is used for this output module. And as you can see, the address of this section starts at Q40 and continues through to Q57, which is the last channel of the module. So remember, we physically connected the contactor coil to the first channel of the output module. Therefore, the address we need to enter for this output in our program is Q40. Okay, so our program is complete, and now all we need to do is save it by hitting this button. Now it's time to test our work. So first, we need to download the program that we just wrote to the PLC. This is the same procedure as we did for the hardware. There is an arrow icon in the toolbar pointing towards the PLC, and we will use this to download the program. Right now you can see that the arrow is disabled. This is because we have installed PCS7 on this computer, and currently we are using step 7 through PCS7. So, what is PCS7? Well, it's a high-end software application for the Siemens Distributed Control System, or DCS. And when it's installed, all of the Siemens automation software applications, like Step 7, WinCC, and other software needed for designing distributed control systems are installed too. If you have only installed Step 7, the icon will be enabled, and you can use it to download the program easily. But here, the icon is disabled. So we need to use the PCS7 method of downloading. So let's look at how to do this. First, we need to get back to the SIMATIC and click this Online icon here, which opens up a new window. This green line shows us that the window is an online window, which means that the data shown is coming directly from CPU of the PLC. So whenever you see this green line at the top of a window in Step 7, it means that the window is in online mode. This indicator here is telling us that the CPU is in run mode at the moment. And as the window is online, if we change the mode to stop, the indicator changes too, showing that the CPU is currently in stop mode. So let's put the CPU back into run mode, and then click this toolbar icon so that the 2 windows will tile side by side. Now, the left window is the offline window containing the computer's data, and the right window is online, showing the CPU's data. Okay, so now we want to download the OB1 to the CPU. So first, we need to open the blocks folder in both windows. Then we can drag the OB1 from the offline window to the online window. This transfers the program from the computer to the PLC. These SFBs and SFCs here are system blocks that reside permanently in the CPU. So we haven't downloaded these blocks too. They exist in the CPU permanently by default. So now we need to add a few inputs and outputs to the PLC simulator so that we can use them to test our program. To do this, select Input Variable from the Insert menu, which allows us to add an input. We can see that the address of this input is IBO by default, which means byte number 0 from the PII. These 8 boxes represent the 8 bits that together form the byte. The address of this first box is IOO. The next one is IO1, followed by IO2 through to the last one, which is IO7. Now, as we also have an output in our program, we need to open the Insert menu again, this time selecting Output Variable, so that an output byte will be added to the simulator. The output's address is QBO, which means byte number 0 from the PIQ. So the address of this first output is QOO, and the next one is QO1, continuing in sequence through to QO7. But the address of our output is Q40, so we need to change this address to 4, with the other addresses following in sequence through to Q47. Before testing the program, we can click on this toolbar monitor icon so that the program will go into online mode, allowing us to see the signal changes online. Okay, so now all the equipment has been connected to the PLC's inputs and outputs. We've written the program and downloaded it to the PLC, so now we're ready to test the program. If we hit this switch, the program should send the signal from here and energize the coil. Now you can see the signal is passed from here and has energized the output. In this animation, we can see that the PLC now sends a command to the contactor, and as a result, the motor is turned on. Now, when we remove our hand from the switch, the input signal to the PLC disconnects. The contactor contacts open, and the motor turns off. We've used an animation here to show the program's testing more clearly. However, you can test the program yourself by activating the IOO here so that the output turns on, and then by deactivating it to turn the output off. Okay, now we're going to test the program again, but this time we'll do it step by step so that we can see exactly what happens from the point when we activate the input by pushing the button up to the point when the motor turns on. So when we hit the button, a 24-volt DC signal is sent to the IOO input. The input module converts this electrical signal to data that can be processed by the CPU and delivers it to the CPU. The CPU receives the data. It looks at the program that we downloaded to it. Program, when the IOO input is active, Q40 should be instantly energized. So we can see here that the CPU sends a data command to Q40 to tell it to become active. The Q40 output accepts the command and becomes active, sending another 24-volt DC electrical signal to the contactor's coil, thus energizing it. As the contactor coil is energized, we can see here that its contacts close, and as a result, the three-phase power is delivered to the motor, turning it on. So that's our program operating successfully now, but you may have noticed a deficiency in it. When we take our hand off the switch, the input signal to the PLC is disconnected. This means that the motor only ever runs while the button is pressed, which of course is not really very useful. To be useful, we need the motor to continue running after pushing the button once and taking our hand away. In other words, after pushing the input once, the output turns on continuously. What kind of change do you think we should make to our program for this to happen? Go to the next lesson and discover how we can do this.